With our MAP 301, a reminder that MAP is an acronym. It stands for machine or the reflow oven. A is our assembly, or in electronics, it's the printed circuit board. And then P is the process or thermal profile that we're trying to achieve. Today we'll be looking at data extractions in the spreadsheet and summary page. We'll be looking at our preference file directories, talk about templates and database files, and SPC. So with that, we'll go ahead and jump over to the software. And again, you'll notice that we are on the latest version 2.18J. The version number should always be up in the upper left-hand corner of your title bar. And then your current working directory that you're in will be directly after that. So we're looking at our data extractions. If you've taken the 101 and 201 class, you know that we have data extractions for our profile tab where we can have different measures. And these different measures look at these measurements over the individual channels, meaning that we have one profile run of multiple channels, and this data extraction will look at that value over multiple channels. When we look at our spreadsheet here is for file management, and it's also for looking at like-type data over multiple runs. So you can see we have some different user fields. We have the name of the data run. In our first column, the date and time that that data run was created. We have 5 user fields. These user fields can be set up to be anything you'd like. If you want to have machine name, we can enter machine name. We can put in an operator. Leaded, lead-free. Maybe this is the assembly or part number. And these are simply columns that you can use to help identify the profiles as you take them. Every time we download a new profile into our working directory, it will load it into this spreadsheet format for us to look at. So we can identify that I took this profile on February 22nd, and it was a leaded profile. And then if I had an assembly number, I could put it in here. Could be a customer's PO, whatever is appropriate for your profiling needs. And then you see we have some different values up here that look very similar to our profile values. Here we happen to have our peak temperature, maximum temperature, only this is for a specific channel, in this case channel 1. And it's picking the peak temperature from channel 1 over multiple profiles so that we can look at a single measure over multiple profiles and glean some information off that. If we know that all of our runs are lead-free, that means the peak temperature should always be within a certain lead-free parameter, which you can put a spec limit around. You can see that the peak temperature is 226 on this run. It was 230.9 on these 2 runs and 226.1. So there's red bars on these 2 runs, meaning that the peak temperature exceeded our spec limit for these 2 profile runs. That spec limit was entered when we added this content into our spreadsheet. I'm going to go ahead and do an edit content here just to show you how this is entered and or edited. You can see that we have a choice of what type of information we want to extract, whether it be a temperature value, a time value, a slope, a temperature delta, a conveyor speed, an integral or total heat area underneath the curve, or special values. We'll get into those later. But in this case, this is maximum peak temperature, so we're going to extract a temperature value. And then here's where we choose the channel number of which maximum temperature value we want. Again, we can't get the peak temperature off of all channels, off of all profiles, so we need to choose a single channel. If we wanted to have 6 channels, we would have to have 6 data extractions, one for each channel, across all profiles. So we say we want a temperature value. What kind of temperature value do we want? We want maximum temperature. We want a minimum temperature, a temperature at some type of time reference. We want an average temperature or standard deviation. In this case, we wanted peak, so we chose maximum. And then we can constrain that value just like we can in our Target 10 tab, or KPI tab, excuse me. So we can constrain it to after the process origin, to within a magnified window, within a machine model, or to a specific zone. So if we're only concerned about peak temperature in the last heated zone, we could constrain it to that. Gives us a choice to choose our zone numbers. We could say between a temperature value, upper and lower, or from a certain temperature to peak. In this case, because it's peak temperature, we don't need a constraint on it. We can just say we want every data point that's in this profile to be considered. We can format it to give it more significance or not, or to help easily identify it in our columns. And then we can put in our upper and lower specification limits. In this case, our upper limit was 230 degrees. We said we don't want any profile that we ever do to exceed 230 degrees C, and it should never be below 210. So that's what it's looking at when it does its spec limits for this particular measure. It's 230 to 210. I'm going to go ahead and reset this filter. And you can see anything with the red bar has exceeded that spec limit of 230. We have several measurements here. To add another measurement to this group, we simply right-click where it says right-click here to add content. We're going to add another measure. And in this case, we'll put in a time value. We're going to choose the thermocouple that we're interested in. In this case, I'll take channel 2. And we can choose a time above temperature, time between temperatures. This would be a soak time. Time above is time above liquidus usually. We can put in temperature references. We can look at just the rising time, which means if we constrain it, we can look at just the part of the profile where the temperature is increasing, or we can look at just the cooling side of the profile. Normal time above liquidus contains both rising and falling, so we can put that in. We can enter the value that we're concerned about. In this case, we're going to say 217 for our lead-free profiles. If we were doing semiconductor stress testing, maybe we want to be within a certain temperature of peak. This is a specific measure that was put out for our semiconductor friends. And it's usually they look for a value within 5 degrees of peak. So it'll find the peak temperature. In this case, let's say it's 225. And then we want the time above 5 degrees below, so it'll look for the time above 220 in that case. But for this value, time above our liquidus temperature of 217, or 221 if you like. And then again, if we want to constrain it, if we want to, we'll constrain it to within our machine boundaries just for fun. And then we can format what this is going to look like. I'm feeling particularly in the Halloween spirit, so I'm going to make an orange cell with black text. And then we can put a specification limit. If our time above liquidus upper spec limit should not exceed 90 seconds, but should be at least 60. Then we can calculate how many decimal places we want to calculate out to. So I'm going to say finish. So here is my value. I've constrained it between the oven. That's what these two vertical lines represent. Our time above temperature is 221C. I'm looking at channel 2, and you can see that all of these values are blue, meaning they are below my specified limit of 221. I'm sorry, below my specified limit of 60 seconds. So they have a blue bar to the left of them. If we wanted to do SPC on this data, we would simply check these check boxes on the top, and they would be added or populated to our SPC chart on our SPC tab. And we'll get back to this a little bit later. Here you can see the 4 values that are checked from our spreadsheet. Of course, SPC is only valid for like type data runs. That's why we give you these filtering capabilities. So if we want to look at only leaded or lead-free profiles, we can. And you can filter on multiple columns. So you can enter in, again, the data that is appropriate so that you can easily identify data runs. And then you can use the filtering capabilities to filter to like type data. Of course, because we give you the ability to easily work within working directories, it may be prudent to collect data in a working directory and not have to use this filtering feature. Excuse me. These data extractions that we put onto this spreadsheet tab can be saved as a template. So you can make a custom template based on an individual customer requirement for your own internal audit requirements. And what you do is after you get the measurements that you're interested in, you would say, save this template as Acme requirements or whatever you would like. And that way you can recall it later by simply right-clicking and saying load template, and then choose the template that is appropriate for what you are wanting to look at. This loads all of the spec limits that you've entered, the SPC visibility, and all of your user identified fields. You'll see that all of these have an extension of TSH. That stands for Template Spreadsheet, and it is located in our default template directory. We'll get into this a little bit later on why we're talking about that. So anytime you create a new value, if I add more content here, say I want a temperature delta, I can say I want the maximum temperature delta for these 3 channels. By the way, I'm on this 3-channel sample. That's why I only have an option of 3 channels here. If I was on the 20-channel sample, I would have 20 channels to choose from. I don't want to constrain this, or maybe I only want to be within our oven again. Or maybe I just want to be within 180 degrees C to our peak temperatures where I want to look for my maximum delta. Here again we can put in some identifying color, and then we can say I don't want my delta temperature to exceed 5 degrees C on any profile run. Now it's looking at channels 1, 2, and 3 from each of these profiles and extracting the maximum delta temperature from 180 degrees C to the peak, and these are the values that it extracted. You can see that I only have a couple of profiles here where my delta T is within my 5-degree specification. Now, as soon as I navigate away from this spreadsheet, it automatically saved this template for me under its default name, which happens to be my Acme template right now. Something to note that if you make changes to your template and navigate away, it automatically saves those changes without telling you. So be aware of that. Okay, so we'll get into our summary. Again, our summary tab is a tab for you to make a custom report, and it can be customized and templates made just like in our spreadsheet tab. There are some random images on here. You can see that when you click on something and drag, that it has blocks. These are actually cells that are editable, and I'm going to turn on the visibility for those so you can see them. Here are the grid lines for each cell, and I'll turn on the headers as well so you can see those. So this looks very much like Microsoft Excel, although it's not. So some of the functionality that you would expect may not be there. These are resizable so that you can make small or large columns. When we put in a value, normally what we would do is select an area. In this case, I'm going to edit content. Or actually, let's just get rid of content. So you can see I have a group of cells here. If I want to add content, I can choose an area, right-click in the upper left-hand cell. I'm going to say Add Content. And what type of content do I want? I can put in individual measures, just like we did on our spreadsheet. You know, we have our temperature, our time, our temperature deltas, our integrals, or we can put in what we call special values. Special values are items that we can populate that aren't individual measures, basically. We can put in things like the file name, the KPI data table. So with one item, we can put in our entire data table from our KPI tab. If we go over here, go to KPI, this is all we have on our KPI. Again, I'm going to load a template to bring up a... Now this is our data table in our KPI tab. If we go back to our summary, that's been populated in our summary for us. So whatever is visible on our KPI data table will now be visible on our summary sheet. You can see this is a special graphic as well. If I want the actual profile graphic to be displayed, I can add content, special value, and that's basically a graphic, and it's our profile graph. So there is our profile graph. Here you can see our assembly is a Acme 123. We put in the assembly drawing with the thermocouple locations. We've got in this very tiny window, let me delete this and make it bigger. Maybe we want a bigger area to show our profile process requirements. So I'm going to select a large group here, add content. This is another special value. This happens to come from our process. And so our process spec image would be the target profile that we want to hit. Here you can see our ramp rate, 3 to 6 degrees per second. Beginning of our soak is 155. The end is 183. Our range is supposed to be 60 to 90. Here's our peak, 210 to 245, with a time above of 60 to 100. And then we have our profile with the same process windows displayed over here. So the customer can easily compare whether this profile looks like what the solder paste specification is asking for. And this seems to be a very nice way to show people this is what we're supposed to get and this is what you have, so everything is good, rather than giving them a table full of numbers that they don't really understand. Like I say, these are all customized. This template format, you can put in your company name for the customer. You can put in custom logos if you want to put in your company logo. Again, it's a special value. You can select a group of cells, add content, and maybe I want to add an image file. So now I can go out and find an image file. I don't know what this is. Hopefully it's okay. No, that's E.H. Lim. It's our director of our Asia territory in Singapore. So I've added him to our default summary page, our one-page report. Again, here's an example of individual measures. This happens to be the minimum temperature on channel 1, 2, and 3. These were all added individually by putting in a specific measure, maximum temperature within the machine, etc. And then this title bar was added as a special value, and you can see channel 3 location. So these title blocks were put in. All of these individual measures were put in, so you can see there's 3 times 7 measures there. That's 21 individual cells that were formatted, including an extra 7 for the title bars and an extra 3 for the side. So you can make a very intricate summary page if you would like. Just make sure you save it often. And like I say, we would save this template. And because EH has pictures on it, we're going to say this is our EH default template. And again, it's going to be saved in our template directory, but you'll see the file extensions here are TSU, meaning template summary. So now if I need to run a template or a summary for EH, I can pull up EH's profile. I can go over here and say maybe these are all EH's profiles. So now I can quickly filter down the only profiles I've done for EH. Then I come over to my summary. I'm going to load a template. I'm going to get EH's default summary template. Now I can quickly print off all of the information that is relevant to EH and his profiles. Okay. With that, we're going to go into, excuse me, get a good sample file to work with here. We're going to go into our preferences, of which there are many. If we go to our preferences, you can see that we have a row of tabs across the top. The first one being our profile tab. Our profile tab gives us defaults like our temperature scale, whether we want C or F. If we have a UV profile, we can choose milliwatts per square centimeter or milliwatts per square inch. We have an anemometer. We can choose imperial or metric. Feet per minute, meters per minute, etc. And our percent humidity. We have our x-axis units. By default, we set it to relative time, which is by far the most popular, meaning that we start at 0 and we start incrementing up from there. You can see this starts at 0 and counts out. This profile is a little over 5 minutes long. We can also choose absolute time, which would be time of day. You can see that this profile was taken early in the morning, about a little after 8, and concluded at about 8:17. We can do data points. These were basically the number of points that were taken. We started at 0, and we got over 3,000 data points in this run, which is quite a few. Point by point, or if we have a conveyor speed entered, it will do a time divided by speed measurement and show us the actual distance. So 100 centimeters, 200 centimeters, 300 centimeters into the profile. Again, this x-axis starts at the process origin, which we can't grab because we're in our preferences area. Like I say, by default, we are on relative time, which is the most popular. We can choose our distance measurements, either imperial or metric. We have our automatic file name convention, which means every time we download from the mole and we get a save file dialog box, this will automatically put some values in there to name it. In this case, it's going to take some of the assembly name and the date and time and use that as a prefix to your file name. You can choose to keep this prefix and have that be the default file name, or you can manually type over it. You can choose things like the oven name, the assembly, the process, or the solder paste, the computer name, or date and time. It's defaulted to assembly and date and time, but I prefer to just have the date and time as the default, so that's what I'm going to leave there. And then this is our default template file. This is our template file that we're looking at this particular profile in, but when I download a new profile, it's going to look at one of these, in this case customer ABC template, as the default. This happens to be the last one I loaded. So it is my default. Again, it opened up our template directory to find that, and these are TPF files. TPF extension is for our KPI data table. All of these templates can be shared. Simply have to go to your template directory under your CECD Megamole map /template folder, and you can share these with your colleagues. Some of these templates will automatically be transferred with your data files if you send an XMG to one of your colleagues or customers. The TPF file, or this KPI data table, will also be transferred with it, and they can save it locally on their machine. On the profile itself, we have some preferences that we can choose. Our auto scale, meaning that we're going to choose the Y scale on this side, what the minimum and maximum value will be. And we can decide whether we want that to include just the profile temperatures, meaning that we would use this to scale, or if we want to include the recipe values, which are usually significantly higher than the profile values. In this case, we've chosen to have it auto scale based on the recipe values as well. And then we have our target 10 feature, which is our pass-fail, green-red. In this case, you can see it's green. We can just decide whether we even want that visible or not. If we're not going to utilize our target 10 capability in the software, we can simply uncheck that and hide that so that it is less confusing or ambiguous. We can decide how many divisors we want on our y-axis. You can see that we've got 2 on here currently. We can choose to have up to 4, and we just split up this profile into smaller chunks for you, depending on how you want to look at it. If you like a very clean looking profile, we don't have to have any in the middle. We just simply have the top and the bottom, and you guess it all the rest. Our alignment method, this is what we do to negate channel offset. In this case, you can see that some of these channels look like they go on longer, and that's because we've chosen to align the peak temperatures of all the profiles with one point in time or one point in distance, and this happens to be the end of the zone with the highest set point. So this is our zone with the highest set point. We go to the end of that zone, we align all the profile peaks to that plane to help get them aligned in time. We have other options. We can choose not to align the profiles at all, and you can see in this particular case, these channels entered the oven early, and then these came a little later, and then this one came even a little later after that, and that's because these thermocouples were physically, dimensionally different. They were on a pallet, and we had a row of them in the front, a row in the middle, and a row in the back. And so this time offset or lag, as you can see, is apparent in the profile. And if we didn't align, that's what the profiles would look like. We can also align on dimension. This is if you have your assembly set up correctly, which I'll show you in a little bit, or just align all the peaks, which is what we've defaulted here. We have the background color for our profile, which can be set here. If we wanted to, we could make it bright and pretty, or choose something that's a little less obnoxious. Then we have what's called a report, and we can include the KPI or profile tab in this report or not. We can also password protect. The MAP software only has one level of password protection. And so if we password protect it every time we want to go into this profile tab, we would need to enter the administrator password set in the software. We have our machine. When we look at our oven conveyor speed, we can choose what its default measuring scale is, or units of measure, centimeters a minute, inches per minute, feet per minute, depending on what you prefer. The zone size measurement, again, imperial, metric. And then we have some default directories. We have a machine directory, which by default goes to our Megamole Map machine. And then we have what's called a recipe directory. Now recipes, again, shockingly, are saved in our recipe directory. And these are linked to ovens. So if you share a recipe, the oven for which that recipe was made will automatically be linked. So if you choose a recipe in MAP, the accompanying oven will automatically be chosen for you. We can choose whether to include this on our report, and then we have some options here for different types of ovens. So if we have an oven that has specific convection settings that you're utilizing and you want that to be visible and editable, we can check, make sure we check this so that we can put in oven zone convection settings. If you have an oven that has different speeds, different conveyor speeds, which in the solar industry they have some conveyors in between zones that run faster than the main conveyor for these very long ovens, you can actually check this and then put in individual conveyor speeds for each zone in the oven, which we'll show to you in a second. We have our assembly. This is, again, our printed circuit board. We have some default units of measure. And then we have, again, our default directory where our assembly information is going to go. Again, another big shocker, into our assembly folder. And then we have our image directory. This is where we have physical pictures of the assemblies. And we use the same assembly folder for that. We have our process or our solder paste. Again, we can choose our units of measure. If we're doing curing applications, maybe we want minutes and hours. If we're doing solder, seconds is probably appropriate. And our slope convection or convention, whether we want degrees per hour, per minute, or per second. And we have another set of template directories. So our solder paste goes into our process directories. Our target 10 spec will go into our target 10 spec directory. Again, fiendishly cryptic into where we load these and save these files. Our summary that we looked at. Our default template, again, with the TSU extension, will be in our template file folder. And we can choose what our default template should be for the as our default. We can choose to show our rows and grid lines. Keep note that if these rows and grid lines are visible in your summary, they will print out. So quite often you will turn these on when you're creating a summary page for formatting use, and then you will hide their visibility for actual printing and utilization of that summary. We can choose to include that in our report, and we can also password protect it. Same with our spreadsheet. Again, we have our default template. What we'd like to have is our normal default, so we don't have to change it every time. We can tell it whether we want to show spec limits or not, meaning the rows of red and blue bars. And then we have our summary stats, our row column labels, and our grid lines. Those are all visibility defaults that we can look at. I'm going to cancel out of here just so we can show you that. So again, we're seeing our grid lines, our row and column labels. If we turn those off, you can see that it takes them away. Our summary stats are at the bottom, which you can now not see. They give us basically the number of runs that we're viewing, the minimum, the maximum, the average, and the standard deviation. And then again, here's our upper and lower spec limits on the bottom too. Whether to include this on the report, and we can password protect it. For SPC, we can choose, and again, let me cancel out of this so I can go to our SPC. You can choose to have an individuals chart, which means that we're looking at each individual measure of each individual profile in our spreadsheet. And here you can see we're looking at 10 profiles. Because it's an individual's measure, we don't show you control limits. We show you spec limits. Here's the upper and lower spec limit for our peak temperature. In this case, we're looking at maximum negative slope. Here's our upper and lower spec limits. Here are the individual values. Because we have spec limits set on these, we can calculate CP and CPK. This is a temperature delta, so we only have an upper spec limit. And without a lower spec limit, we won't be able to calculate CP and CPK for you. If we change our samples per subgroup size, now we're doing a rolling average or an average of averages, depending on how many we choose here. Once we choose a normalized chart or increase our subgroup size beyond 1, it's no longer an individual's measure. So you can see our CP and CPK values turn pink, meaning that technically we can still calculate them, but mathematically they're no longer valid because we are working on an average. You can see that our spec limits have now turned into control limits. So we have our upper control limit and lower control limit automatically calculated for you. Every time that we download a new profile, a new data point will appear in this, and the upper and lower control limits will be recalculated. Again, we can choose our subgroup size for this rolling average based on your requirements. Again, if we choose 1, it's an individual's chart, and we're looking at spec limits and CP and CPK. We can choose whether we want to include this in our report or password protect it. Then we have our mole. This mole status is a small bar that's usually right here on the bottom of the screen, and it will show us things like the current battery condition of our mole. This only works while it's connected, by the way. Shows you the internal temperature of the mole, what it's connected with, whether it's USB or RF. We'll show you the mole name, which there's no mole connected now, so that's not being populated. Be aware that when this mole status is active, which it is by default, that we go out every 15 seconds and talk to that mole. So you may see performance problems if your computer is older or low on resources, because we do need to access ports and do some communications. So every 15 seconds you may see small delays. We can choose to include this information on our reports or not, and then we can set our calibration interval. Every time we do our pre-flight checkout, we have a reminder if you are out of cal. So if you're a high reliability company that requires a 6-month calibration interval, you can set that here. By default, we set it to 12. And it will check the internal calibration date of your instrument to make sure that you're in cal. Note that this, if you're not in cal, it's not going to be populated anywhere on any of your reports. So we just remind you, but we won't tattle on you. The mole itself, you need to update the firmware on our Mega products. You can use this feature. It's a firmware loader that you would have to get from our tech support department to upgrade your firmware if an upgrade becomes available. Note that if you get your instrument calibrated here at ECD, that we will do that for you automatically. And then miscellaneous language. Right now, we've got actually 4 languages that we support, and it's growing slowly. We've just added traditional Chinese for our friends in Taiwan, and German is being translated as we speak. This is our MRU, most recently used files, so you can choose how many to remember. Note that this doesn't always work for some reason. If we want to change our default password, which is in our help system, you can change it here. And then we have password protect engineer mode. You can see that we have the mode switching. We covered this in our 101 class. We can actually password protect that to prevent people from getting into engineer mode and mucking about with all the valuable data that you've made and templates that you've created. And then we have authorize. If you're using a trial version, you would hit this button and it would bring up your trial dialog so that you can get the registration number to authorize your MAP software. Okay, with that, we'll look at one more set of preferences, which is our show on profile. You can see over here in the upper right-hand corner, we've got some data, and that is visible from this dialog, which is show on profile from the profile pull down. I'm going to go ahead and turn on all these things, and we'll go through them one at a time and turn them all off again. So we have this box in the upper right-hand corner. You can see that we have our map information, our machine, which is, this case happens to be a Heller 1809, our assembly, which is a MegaRider 20, which is visible right here, and our process is a Kester Easy Profile 256 No Clean. And then our file name, that's the actual name of the data file, happens to be ECD MegaRider U20 Sample XMG. When we ran this profile, the max internal temperature of our profiler was 29.47 degrees C. The battery was at 4.2 volts. We were set at 0.1 second log interval. We logged 3,700 data points on September 30th of 2009. And our OK Target 10 button was never pressed, so we'd have no result. So all of these things tell us about what happened when this profile was taken. And we can choose to have this visible or not. And we can turn off the things that we're not interested in. If we want to see the log interval and the number of data points, we can turn off the battery voltage and the maximum internal temperature. Maybe we want to see these zone boundaries. Those are nice to see. And I want to see the conveyor speed. But I don't really care about the oven name over here. And my customers don't really care about it either. So I'm going to turn that off. Our assembly name, maybe we want to leave that on there. Shows our customer that we're actually naming these profiles and that it's specific to them. our target 10 diagram, that's these solder paste windows for our process. I'm going to leave that on just so I can show that to my customer. But I'm going to turn off the process name, and I don't really care about this target 10 result because I didn't push the button, or I don't have a profiler that has that feature anyway. And then for the data run, I don't really need to know the name of this file, but I do want to see the date and time. So I've selected those things that I want visible. And now I've got my assembly, got my log interval data points, and the time and date that it was set. Just another preference. Okay, with that, I think we'll pop back over to the PowerPoint here real quick. And get down to the end. This PowerPoint will be emailed to all participants afterward. In summary, we looked at our data extractions for our spreadsheet and summary. We looked at our preference file directories, templates, and database files. And we talked about SPC. So I'm going to open it up. Any questions? Anything I didn't cover? Everything's open territory. If you wanted to see something that you didn't see, bring it up now and we'll go through it. Anyone? Oh, I've unmuted the phones now, so if you want to talk, you certainly can. And Mike asks a question that he has a SuperMole Gold. Is it a free upgrade to Megamole? Megamole is a device. The map software is backwards compatible with SuperMole Gold. And I would say check back in around Apex to see about upgrade options. Right now it is a pay software. So you get 30 days to try it free, and then we give you 3 licenses for about $800.
All right, appreciate that.
No problem. And also, if you download it today, you'll get a 30-day trial. And then if we do a future release, you'll get an additional 30 days. Anytime that we do a release, you get another 30 days to try out that release.
Okay.
So if you get it today, we are doing an Apex release as well, so you'll have it for at least 60 days if you download it and try it out today. And that may carry you through until we have upgrade options.
All right, appreciate that.
No problem. Any other questions?